Next, we've got one of our teams from the Accelerator. Excited to introduce Michael from Zero Gravity. They are building the next generation of modular AI blockchains. So, Michael, take it away.
Cool. Well, first of all, shout out to Nick and Celestia for creating the modular ecosystem. We're truly standing on the shoulders of giants. So it's really exciting that I'm introducing today Zero G, or we've also been known as Zero Gravity. We're basically building the first modular AI chain. So we essentially help people launch AI DDApps through the fastest data availability layer. And you now know what a DA is, so I don't need to explain that, and my presentation's done. No, just kidding. We'll keep going. So let me talk a little bit about the team that's building this. So myself, I'm a serial entrepreneur. I started a unicorn company before, went through Y Combinator, summer 2016. Basically also worked at Bridgewater before, Bain & Company, as well as Microsoft. So I'm a bit of a hybrid, both technical as well as very well versed on the business side. In my company, also drove about 100 million of contracted ARR before. And then basically through Thomas, who you see on the right-hand side, my grad school buddy from Stanford, I met Ming and Fan. He called me up late 2022 and he said, hey, I invested in Conflux. You need to chat with these two co-founders. They're the best technical co-founders I've ever met. I think you guys would be a great match. And then 5 to 6 months later, I exactly told them that these are the best engineers and computer scientists I've ever worked with. Bing spent 11 years at Microsoft Research. He wrote some of the first AI algorithms for Bing, also decentralized storage expert, and wrote some of the key papers like Tango and Curfew in the space. Fan has been a hacker since a young age. He holds 2 Olympic gold medals in informatics. Fun story behind that. Once he won the second one, I think China passed a law that you can only go once to the Olympic informatics. And so he's the only one that actually holds that. He went to MIT as a computer science PhD and is now a University of Toronto professor. And then he was actually an intern for Ming. And that's how they met and then started Conflux together. And we basically came together and wanted to build something on a global scale and something that truly solves really big pain points in Web3 today. And so here's some of the key papers. So we're expert in blockchain scalability, AI. We've won a lot of top paper awards. And so just lots of brain power on this team. Super excited to work together. We've also had tremendous success on the fundraising side just because not only the team, the type of problem we're working on, and super excited to be supported by Hack, BBF, Symbolic, Bankless Ventures, and many, many other great funds as well. And so what's the problem that we're solving? So you heard a little bit about Celestia and data availability, and we're trying to take it one step further. How do we actually get to Web 2 pricing parity? Right now, storing a gigabyte on Ethereum costs almost $60 million. That's insane. Like, why would you want to store data there besides transaction data? And then if you compare it to Amazon S3, you know, it starts at 25 cents, but then, of course, you have to add all the retrievability and so on. And really, 70 to 99% of gas costs are spent on storing transaction data. And so it's really important to solve this problem to get to parity. So in a way, the analogy, it's like, L2s are getting to par in terms of execution with Web 2, but then it's like having a fast CPU and really slow RAM. So we're basically figuring out that RAM part. And so what that means is if you have really slow RAM, you can't build applications like on-chain AI, on-chain gaming, high-frequency DeFi. It's just not possible. You don't have the throughput. So as an example, if you want to scale to 10 million transactions per second across 1 million rollups, as Nick mentioned, you need 5 gigabytes per second in DA capacity. No DA layer today solves this, so somebody needs to work on this problem. And if we don't solve this problem, we're also going to miss the AI boat in Web3 because every company in the future is going to be an AI company. 70% of any administrative function can be automated. It's potentially even more. Given some of the recent research papers, but this is an important problem to solve. And so if you then look at the use cases, well, how do you actually deploy something on-chain AI? So there's a few frameworks. One's called ZKML, one's called OPML. In this case, OPML, so we're partnering with Aura, for example. You need to store the actual model on-chain, If you're trying to store a Llama 2 model, for example, that's hundreds of gigabytes, storing that on Ethereum would be very, very expensive. Nobody wants to do that. So we have to basically figure that piece out. And then once you store the model, you also have to then serve the decentralized inference traces. And so if you have 1 million users, each doing a request of about 100 kilobyte, that's assuming some blended rate of text and video and so on, you're dealing again with a DA capacity of about 1.6 gigabyte per second. So gigabytes, not megabytes. Here's another example. Let's say you're trying to scale an on-chain gaming kind of platform. And in Web 2, like 100+ million users, very common. So imagine doing that on-chain, and you've got 3% of those users saving and loading state concurrently. So then you're dealing with 100,000+ gigabytes per day. That's not something current DA layers can support. And so it's already a problem, actually. So DeFi Kingdoms is an example. With only 20,000 daily active users, they already have a state explosion problem. They have on-chain game logic, and they're dealing with 14 terabyte of data that they need to manage. They're running out of space on their EC2 instance, and so we can help solve all of this. And there are, of course, many other use cases, high-frequency DeFi, data marketplaces, large stream deepin, a lot of different applications that are really high performance that will need a really fast throughput DA layer. And so here's where we really come into play. So this is a bit how the architecture works. So essentially, we start with a client DA data blob. We have a dispersed server. That dispersed server essentially does the erasure coding. It basically splits the data into chunks. Those chunks get put onto different parts of the storage network, not all of the nodes simultaneously. And that actually then creates an aspect of horizontal scaling, the way that we do it. At the same time as that's happening, we write a validity proof and a KZG commit to prove the validity of the encoding to the consensus layer. We have a separate consensus layer. That consensus layer, as the storage chunks are coming in, is doing the data availability sampling. Once it reaches consensus, then we can also write a ZK proof to the underlying L1, let's say Ethereum or another L1, if you will. And so that's the basic setup. And with this particular setup, we can reach after optimizing a lot of integration pieces, we can reach a per node speed of 10 megabytes per second. And because it's horizontally scalable, and we will use a custom consensus that's DAG and POS based, we can scale that to 5,000 nodes. So therefore, the throughput is 50 gigabytes per second. And so that's basically 50,000 unlock compared to dank sharding. And it finally gets us into a territory where we can drive costs low enough that we're actually competitive with Amazon S3. So if you compare it, for example, against all of the other DA layers, so ones that are starting to approach this type of speed is like Solana Firedancer, for example. But then generally, if you look at the cost, you're looking at about 3,000 to 13,000 per gigabyte per month. And we're going to price at $50. So that true high-performance applications can actually be built on-chain. And so we're also not stopping there. We're going to introduce the first programmable data availability layer. So what that means is you can customize what the data type is, the number of replications, where it's stored, what the data persistence is. So you don't need to worry about data pruning after 30 days, for example. You can just keep paying or stop paying, and then the data automatically gets pruned. And so that's why we started with a decentralized storage network as part of this design. And even better yet, you can actually save your entire state through a smart contract and load it later, and we deal with all the difficulty in the back end. And we don't stop there. We're also introducing today the first infinitely scalable DA. Not only have we figured out how to horizontally scale across nodes on the consensus layer, but we can also horizontally scale the consensus layers so that you have infinite DA capacity over time. So that as applications are growing in the AI space, for example, let's say you want to do decentralized training. I spoke with one AI company called Manifold, and they said, if we want to do really fast AI training, we need a 50 to 100 gigabyte per second capacity. And I said, bring it on, we're ready for the challenge. And this is how we're doing it. And we don't stop there. With this, you can also do dedicated DA. You can actually dedicate a whole consensus layer to a specific chain, let's say like Polygon or other ones, to have full reliability in terms of transaction costs, in terms of speed. So there's not going to be any spikes because you're not sharing your consensus layer with anybody else. And that's because of our design. And we don't stop there. We're going to introduce the first aggregated DA as well. So say you want to work with Celestia, but you want a fallback option for load balancing, then you can work with us. Or let's say you want to run it in high performance mode, then a lot of the transactions will go through us, but then you also have fallbacks just in case you want to work with Eigen or with Celestia. And then the benefit of that, again, is 100% uptime. You can load and save state to anywhere. And it's really the Web3 collaborative spirit that we're all here for. And so this is my attempt at a very nerdy joke. And I showed this joke to all of our some of our investors. And I got blank stares, exactly all of this from here in the room. So it totally bombed. I totally failed at this stupid joke. And I had to actually explain it. And so it wasn't funny at all. And so when you explain a joke, usually isn't very funny. So basically what this means is you add up all the consensus layers together, the infinite ones. You add the storage, you add the aggregation, and then we don't just have modularity, we have modularity squared. So yeah, it totally bombed. But luckily, we have support from our community, and I was saved. And so really thank our community for helping me out on this one. And so let's go a little bit back to the on-chain AI use case. So we provide kind of the core infrastructure. We start on the data availability side. We also help with the model and the data side, where you can actually store a model, and then serve the decentralized inference traces. And then the execution layer, currently we partner with partners to do AI agents, autonomous agents, ZKML, and so on. And so here's some of our partnership network. You've got kind of the L2s and L1s, like Polygon, Arbitrum, Fuel, Layer N. And then on the AI side, we've got Aura and Modulus Labs, also Stanford Accelerator company, eStorage and Thales, and a bunch of other AI and kind of AI gaming companies as well. And then roll-up as a service providers, of course. And then one thing I should mention too is that we will work together with Eigen and Babylon to actually secure the different and infinite consensus layers, so that we have economic security guarantees that we can provide as well. And so also announcing our roadmap. This is very much a draft, so it might change in the future, but basically in 2 weeks we'll have our public testnet open. We've already been doing a lot of key integrations. Our mainnet phase 1 will launch end of Q2, mainnet phase 2 end of Q4, and the first product that we're kind of bringing to market is this AI DA concept. Then we'll work on aggregated DA, infinitely scalable DA, and dedicated DA, kind of in this order. And of course, going to support a lot of our community through social channels, major conference participation. We'll try to figure out a points program as well. So lots of exciting engagement with our community. And so if you want to get involved, definitely join our social channels, our X, our Discord. Our Discord is full of memes, so you'll laugh your ass off, just like I have. So definitely check it out. Telegram, and then our draft Gitbook is already online, so you can already start looking at some of the code, some of the deeper technical details. So definitely check that out. And so that's it. Again, introducing the first modular AI layer, and join us to make AI a public good. That's our mission. And follow me on X. Check out our website, and also add me on TG. Thanks, everyone.